Welcome to AMS Talks. I'm Rick Bacon, Chief Executive of Aqua Metrology Systems, and I'm joined today by Richard Lawson at Southsea STS. For the past 20 years or more, Southsea have been supporting large companies and small ones and the public sector to gain control of their water transport systems through buildings and large plant. And today, huge sums of money are spent on corrosion control systems, but still corrosion persists. And so I'm going to be talking to Richard about why that is and the value of data-driven treatment systems to better manage and control those water systems and ensure both compliance and protect those systems from corrosion. Richard, welcome to the AMS Talks.
Oh, thank you. Thank you very much for having me, Rick. It's a pleasure.
So you've got a long history of looking at new technologies, managing corrosion in buildings and compliance. What do you see as the major challenges in this industry today in terms of corrosion management?
Well, corrosion is always going to be with us because it's thermodynamically inevitable. We're working at managing it and managing it efficiently so that it doesn't impact the use and usable lifespan of the buildings which we're managing systems in. In terms of the challenges which it faces, it's going to be driven by two things. The first is the cost of the chemicals and the human time and effort it takes to manage it, and the second is environmental factors, both potentially toxicity of chemicals, disposal of them to the environment, but also the carbon budget of this as well. And the reason why we wanted to have a look at the SANUS system is because it potentially offers us a route to remediate on both of these factors, to reduce the amount of chemistry we need to use, to make it safer, and to require less interventions on site, which will save us in terms of carbon emissions.
Great. So I know that you've been running this pilot with this new technology for a little while. It's early days, obviously, but perhaps you could share some of that initial data, because I think you'll find very interesting in terms of what's already emerging.
Yes, let me do so. Just let me share my screen. Here we go. Sorry, I keep trying to get to the slideshow, and Zoom is getting in my way. So what we're looking at here is the water chemistry from the system which we treated before we've flushed it out and then retreated it using the SANUS generator. And it's quite a complicated system. It's fitted to an old building in central London, so it's a retrofit, not a new build, which makes both the physical layout but also the topology quite complicated, because it runs from chillers on the roof of a building on the 5th floor all the way through to sub-basement. It travels underneath the street, and it also serves a second building, supplying chilled water to run comfort air conditioning. We've sampled from 3 different locations. It should be quite easy to work out which one's the bottom of the bit is the basement plant room, where all of the solid corrosion product tends to accumulate. So we've sampled from the basement plant room. We've sampled from the chillers on the roof of the building. We've also sampled from the plant room next to where we're doing our actual dosing. As we can see, it has evidence of historical corrosion, both of copper and iron from the steel. It's not a system which has significant amounts of zinc or aluminium, so we haven't looked for those. And it was previously controlled using an industry standard mix of sodium molybdate as an anodic corrosion inhibitor, and it had a little bit. It was also dosed with non-oxidizing biocides, which I think was a Bronopol mix. So what we did was we flushed out the old water treatment to prevent any interferences and make sure that the corrosion control that we see is actually generated by the stannous, not historical treatment. And then we ran the stannous generator on site and dosed the product into the system until we reached 0.25 milligrams a litre of stannous in the system. And what we can see on our next slide, this is our copper results, and the first set of samples were taken as we started dosing. The second set was when we were part of the way through dosing, and the final set is a week post finishing dosing. And what we can see is even as we start to dose in the stannous, we are inhibiting corrosion in the system at all the different points in the quite complicated system, which shows that its corrosion protection is able to be spread normally by normal pumping operations of the system and didn't need any special boosts or injection in different points to achieve that. And these results are again borne out. So this was our copper results. These results are again borne out by the iron. And again, once we've got ourselves fully dosed, our stannous has brought our corrosion back right down. And where we are now is we're continuing to monitor it after we've reached the low level to gain an understanding of what kind of frequency, if any, further dosing may need to be taking place. And also, as I alluded to earlier, we're going to do a secondary goal, which is the use of stannous as a biocide, and maintaining microbiological control, particularly in a chilled system like this, which frequently reaches temperatures that bacteria can grow in. This is really important because microbial growth, if it doesn't control, can lead to biofouling of valves and valves, sensors, and other control parts of the system. But it also can generate low oxygen zones in a system, particularly if there's any deposits from historical corrosion in low points or low flow areas. And these can, if you've got a low enough oxygen level, it can allow obligate anaerobes, things like sulfate reducing bacteria, to proliferate. And these are a particularly influential cause of microbially influenced corrosion, which leads to pitting and pinholing and early failure of components, which if they're in which, as well as the damage caused by leaking, but they can also cause a huge amount of cost if you can't control it, because of difficulties of shutting down a system, cutting out affected areas, and then cleaning, reflushing, and retreating.
It's really interesting data, and I think that last point 2 points you made in there about cost. One is the earlier point about, if you like, the carbon footprint of managing and supporting these systems, which are obviously fairly labor intensive, and the other is that it's not just the cost of treatment, it's the cost of undertreatment or mistreatment, and then the economic consequences that follow from that through loss of asset use and replacement and maintenance cost and disruption. One of the things that I think will be interesting to talk about is, where does this project go next? You mentioned obviously looking for the biocidal effect, which would serve to, if you like, shoot two birds with one stone. You get the anti-corrosion and the biocidal effect, but also maybe talk a bit about the monitoring component to this, which is sort of, sets it apart.
Yeah, I mean, the benefit of online monitoring is in comparison to traditional methods. So a traditional method is very difficult to automate the monitoring of. I've spent several years looking at possibilities and haven't found anything satisfactory. And what this means is you get snapshots of system performance rather than a continuous view, which gives you real control, lets you get fine-grained control over things. It also is quite labour and potentially carbon intensive as well. If you have to have engineers spending a lot of time on the road driving around doing routine testing, it's a great deal easier and better for our environment if we can monitor things remotely, treat before a potential issue becomes a real problem, and then that frees up engineer time to work on more important things and only attend to the most important issues. So that's something which I think is definitely going to be a potential future benefit of this. In terms of other things, I think we can trial. As I mentioned, we're working with this as a chilled system because this is a very good start. This is a very good starting point because chilled systems have the microbial issue as well, for which lets us work on it. We're going to, once we've finished our trial on this, we're going to test it on a heating network. And as this is an existing system, the other thing I think we'll probably take a look at, which I'll be really keen to see, is how it handles new commissioning, cleaning, and treatment of a new build. That's a slightly different process to this, where all of the transport and construction protections are chemically stripped from a pipework system before it's filled and treated. Mm-hmm. And this, I think, could again show the benefits that we can bring to it with a standards treatment.
Great. Well, we're looking forward to working with you on that. You're great partners. It's great having you over there and working on this with us. Really appreciate the knowledge and experience you brought to this project. I'm very excited by the results. So thank you again, and to the team for everything you're doing. It's been a pleasure catching up with you.
Oh, likewise. We're looking forward to continuing to work with you on this and future projects.
Thanks very much indeed, Richard.
Yeah.
Take care.